All right, today we're doing logarithmic functions. Like I said, in your book, I'm on page 718 if you'd like to follow along. Logarithmic functions are logarithms. This is logarithmic form. And what's this? When it has an exponent. Exponential form. Okay? They are very closely related. All right? This B right here, you move it down just a little bit. It's called a subscript in English if you're, taking notes and you want to, note something. Anyway, you move it down, okay? So this is like your paper. There's the line of your paper. That's how you would write it, okay? Everybody with me on what it looks like, okay? So it's down a little bit in your house. This is how I keep it straight. We don't have a lot of them here in the South because I really don't know why we don't have a lot of them. But not many people have basements in the South, okay? But I call it, it's like down in the basement, okay? That's why I put a B. In your book, it uses A. I'm using B so we can get, okay? That's your basement. Yes?
Because we have more room.
You think so?
That's why.
Probably. I see what you're saying. More room.
Land.
I got you. More land. I got you.
You have a basement?
So we have, this is the base, okay, in the basement. Compared to your exponent form, what's this always been called? The number that's being taken to the exponent. That's your base, okay? So they're the same number, all right? The answer to a log problem, okay, the y here, that's your exponent over here, okay? And then what you're taking the log of is what it is. So I know I'm doing a horrible job explaining this, but all it is moving things back and forth. So this first example, these are written in what? Log form, and they want us to write them in exponent form, okay? So all it is moving things around. So what is my base? 125. What is the exponent on a log problem? It's always the what?
1. So it's going to be 25.
It's always what? On a log problem, your exponent is always your what? Answer. What's my answer? 2/3. And that needs to equal 25. That's literally all you're doing on those problems. You're just rearranging it to where it looks like exponent form. Okay? What's my base on part B? 8. What's my exponent? 1/3. And that should equal 2. Okay? And if you put that in your calculator, 8 to the 1/3 does equal 2. It's the cubed root of 8. Okay? If you put 125 to the 2/3 power, you do get 25. Everybody good? Okay? Example 2, we're going the other way. These are exponent forms, and we're going to write them in log form. Okay? So, log of, what's my base? 4. So log base 4 of what? 64 equals 3. And again, understand, all a logarithm is asking, welcome back. All a logarithm tells you is what exponent do you have to take 4 to get 64? That's what it's asking. That's what the answer is. Okay, so 4 to the 3rd power is 64. Okay, here I'm going to have log. What's my base? 3. It goes down in the basement. Okay, of what? Of 1/27 is going to equal the exponent, -3. Okay? So far, so good?
Yes, sir.
You do these in Algebra 2, but some of us got Algebra 2 cut short because of the not coming to school, and so I'm not sure if you've got to this yet. So if you,
Did we do this in your algebra class?
I don't think we got. Oh, yeah, you didn't have any second semester.
No, I had you in sophomore year.
Yeah, we definitely.
It's been a little while.
Yeah. All right.
Oh yeah, most of us
I'm
did.
so lost in that class.
Any questions? Everybody good? All right. Let's use this now. So the next one, example 3 says log base 7 of 1 over 49. Now you have these rad cool calculators that will do this for you. But if you did not have a calculator, that's what we're going to play right here, okay? I don't have a calculator to do this, all right? So here's what you do. All they want you to do is evaluate it. So what you would say is, all right, I'm going to set it equal to X or Y or D or F or whatever you want to set it equal to, okay? And you change it to be exponent form. So what's my base? 7 to the X power equals what? 1 over 49. And then from there, it's just a matter of getting your bases alike. Okay? What's my base over here? 7. 49. Can we change 49 to where it has a base of 7? Yeah, what would that be? 7 what? Squared. And now, this 7's on the top. Can we move this 7 to the top?
Yes.
If we do, what happens to the exponent? It doesn't go away. It does change, though. Negative. We've been taught never leave an exponent negative. You always move it and make it positive, right? Well, now we don't really care if it's positive or negative. We just need them both on the top, okay? So now that we have the bases the same, what do the exponents have to be? The same. So what's x got to equal? -2. Okay? If you have, I'm still going to show you how to do the calculator thing, because, and I'm showing you this because not all calculators have this ability. Okay, if you go just get a regular 4-function calculator, I don't know that you'll be able to do this. But if you hit math, okay, and I think it's quicker just to go up, and the one that says log base, okay, you can hit log base and basically plug it in. All right. What was my base? 7. What was we taking the log base 7 of? 1 over 49. And then you hit enter, and you get -2. Okay.
On the test, or do we have to show the work?
Show the work on the test.
I don't understand the work.
Okay.
Can we do another one?
We can.
Explain it again?
Yes.
What is this other button?
All right. He asked a very good question. He asked, what is the log button? Okay. That is the log. They give you one. Okay. That base is 10. And so anytime they have one written, so if it says log of 100, okay, everything in math, if you hadn't figured this out, has a few things that are understood. Like when you do a square root, what's in there? A 2. We don't write it though, it's just understood. This is the one for log, okay? If it just says log with no base, the base is 10. Okay? They might write 10, but if there's nothing there, the base is 10. Everybody got me? Okay, so if it just says log of 100, it's saying base 10. Okay? So, to kind of help you out, I would set this equal to x. All right? What's my base? 10. I'm going to change it to exponent form. 10 to the x power has to equal what? 100. We get these bases the same. 100 would be 10 to what power? 2. 10 squared is 100, right? Okay, so x has to equal 2. Okay, we did
Okay, I think about it now.
log base 4 of 64 equals x. So what would we do there?
You said 4 to the x equals.
4 to the x equals 64. Can we change 64 to 4 to some power? 4 to the third. So 4 to the x equals 4 to the third, so x has to equal 3. Okay?
Are they all gonna be like that?
Yeah, pretty much. Every now and then,
Because I noticed with each one of these that you can really just guess
oh shoot, hold on.
which one it is. Like with 7 to 49, you know that 7 squared is 49. And
Yeah,
and then,
you may have one something like,
Bless you. Well, I mean,
this will be as hard as it gets,
okay.
okay?
I'll take a
If
guess.
you have this, all right, so I'm gonna set it equal to x, that would be 4 to the x equals 128. Well, if you go and play the game in your calculator, you'll realize that 4 to some power doesn't give you 128,
Yeah.
okay? So now we have to change both bases. What can I change 4 to? What base could I change 4 to? 2. I could change it to 2 squared to the x. You got me? Okay. Could I change 128 to 2 to some power?
Yeah, it's even numbers.
Figure it out. What would it be? And it's not just because it's an even number. 7. Okay, 2 to the 7th is 128. Now that I have the bases the same, the exponents have to what? Be the same. If two things are equal, everything about them has to be equal. Okay, so 2x equals 7,
3.5.
divide by 2, x is 3.5.
Okay.
That's as hard as they'll be is when you have to change both bases. And we will get to, sometimes you can't change the bases, and we get into anti-logs, and we'll get to that. So don't get too far ahead. I sure can.
We'll get to that in this term.
It's your world. All right, properties of logarithms. These always seem to make sense to me because I know properties of exponents. And as you can tell, exponents and logs are very what? Very similar, very closely related. So when we're doing multiplying like bases on exponents, right? When we multiply like bases on exponents, what do we do with the exponents? You add them. Same thing here. You can separate these, expand these, okay? If you have the log base b of two numbers times each other, you can separate those and say log base b of m plus log base b of n. Notice, multiplying, we can do what with them? Add, just like your exponents, okay? And I know it's written to go from multiplying to add. You can go the other way too. In fact, most of the time you use this property, you are going the other direction, okay? Same thing here. When you're dividing, what do you do with the exponents? You subtract them. Same thing. You can subtract the two logs. You can make them from one log into two logs, okay? Or you can combine two logs into what? One log, one big log, okay? The product rule, when we do a power to a power, what can we do with the exponents? Power to a power. So x squared to the third. What do we do with that 2 and that 3? You multiply them. Power and power, okay? So I can move that to the front where you're just multiplying by, okay? And then the last one is, again, common sense, and I wish common sense was more common. Anytime you see this equals, and I just said it here a minute ago, if you see an equals, what does that mean about the two things? They're equal. They're the same. Everything on each side has to be the same. So if you say log base b of m equals log base b of n, well, are the logs the same? Are the bases the same? So what do these have to be? The same. M has to be equal to n. Okay? It is common sense, but you'd be surprised. Okay? All right? So example 5 here, we have
just never taught that.
3 parts. I know you weren't, or you may have been and just kind of like just kind of said it offhand and it just kind of you didn't really think about it.
Yeah.
But half of math is making things look the same on both sides.
Right.
Okay? So here,
This is example 4.
it is example 5 in the book. We skipped example 4 in the
They
book.
just told me that. They were
Yeah.
too shy to tell you.
I got you. They don't need to be too shy. I'm not going to bite their head off. I'm not. I'm not some crazy Batman or maybe I am Batman. Anyway. All right.
See, Batman and Coach Todd, the same room together. Just saying.
This is true. Where's Rachel? No, okay, I'm sorry. All right. Example 5. We are solving it for the variable. So, in order to do that, let's change it to exponent form. So, what's my base? P. What's my exponent? 1/3. That's not my exponent. That's not my exponent either.
1/2.
1/2. Remember, the exponent is always the answer to your log problem, okay? Equals what? 64 to the 1/3. So what is 64 to the 1/3? We can go ahead and do that. Is that 4? Is that right? Okay. And what do we do from there? How do we get rid of the 1/2 power? Reciprocal.
You do the thing.
You do the thing. The reciprocal thing. What's the reciprocal of 1/2? 2. So we're going to take them to the second power. And P equals 60. Bada boom, bada bing.
That's a lot easier than I thought.
Okay? Yeah, logs are just kind of scary looking. They're really not.
Yeah.
They're like
really scary.
they're really just a big teddy bear when you get to know them. Yes, they are. Part B. Looks really, look, I love these because you show that to like a little freshman, they're like, oh my gosh, what is that? When they really look at it though, is that really that hard?
No, you just add,
No.
you just do
These are what?
the same.
The same. So these have to be what? The same. So forget about the rest of it.
2x
Just 2x plus 11 equals 5x minus 4. And work it. It's a good old
I hope I don't fall.
algebra problem. Divide by -3. X is 5. Okay? You move your 5 over, make it negative at 5x. You move your 11 over, make it negative 11x. These cancel. You're left with negative 3x equals negative 15. And you divide by your -3 and get your answer.
I was confused when you said -3, but I did it the other way.
Okay, okay.
I'm doing good.
That's fine. You would have had 3x equals positive 15 over positive 3. So, all right. And our last example, and we can do more if you want me to. C. Can we do on C what we just did on B? No, because how many logs are on the left? 2, and there's only what? 1 on the right. So we need 1 log on both sides in order to do what we just did. Can we make these 1 log?
Yes.
How? They're what? Adding. So how can we combine them? By multiplying. So this will be log base 11 of x times x plus 1 equals log base 11 of 6. Now, this and this and this and this are what? The same. So all you need to worry about is x times x plus 1 equaling what? 6. So I'm going to go ahead and distribute. That'll be x squared plus x equals 6. How do we work these? Because this is getting more, this is what kind of equation? It's a quadratic equation, so we need to set it equal to 0. Okay? This is where you have to do your completeness square, quadratic formula, factoring, graphing, one of those things, okay? That's the way I'm going to do it.
Oh, okay.
I'm going to move my 6 over.
Oh, when you said set it to 0, I thought you meant both of the parts set.
No.
Okay.
You set the entire thing
Right,
equal to
yeah, that's
0.
what I did.
So that will be x and x, what two numbers multiply to be -6 and add up to 1? +3
Negative.
and -2. So this x will equal -3, and this x will be +2.
So you have two answers for that.
Okay? Correct. All right. Now, when you get two answers, what do you think? What do we usually have to check? Yeah, because sometimes we get answers that don't work. Okay? So, if you look at our original problem, I want you to think really hard, okay? If I were to plug in, you don't have to get too far. If I were to plug in -3 here for x, okay? Think about what that's asking us to do. That's asking us to take 11 to some power, and it needs to equal what? -3. Is there any number where you can take a positive number, multiply that positive number by itself some number of times, and that positive number become negative? Think about it. Don't just say no. No is right. But y'all see what I'm saying?
Right.
Okay. It is impossible to take a positive number and take it to an exponent, no matter what the exponent is. Okay? And get a negative answer.
It's just going to keep going up in value.
Correct. Or down. Because
Oh, yeah.
a lot of people think, well, you can do, 11 to the -5th power. Well, that actually doesn't make the number negative. That makes the number
Smaller.
small. That makes it 1 over 11 to the 5th power. Okay? So you have to be very careful. You can't have a negative that you're taking a log of. You got me? Everybody with me? Okay? You have to be careful about where the x is. If the x was a base, could it be negative? Could a base be negative?
Yes.
Yes, that's okay. But you can't be taking the log of a positive number and it of a negative. Is that making sense? Okay, so that's an extra solution. If you want to get really fancy, it's called extraneous, okay, solution. And basically that's just a solution that it works mathematically, but it doesn't work. All right?
Oh God, what's the point of doing it? It works mathematically, but it doesn't actually work.
It's just called, real life and stuff. So,
That's why I hate math. Like, oh yeah, it works mathematically, but oh no, it doesn't
well,
work in
that's
real
when you
life.
get into like imaginary numbers and stuff like
What is the
that.
point?
That's the
What was the
dumbest thing.
reason?
It's, hey,
What's the point of that?
I
That's
hate imaginary numbers.
if you can do it in real life, you should be able to do it in math.
Don't start me on imaginary numbers.
you would think, but,
Math can have
it's a lot of
imaginary
things.
numbers. I should be able to have imaginary numbers.
Yeah.
Lots of people do have imaginary money. It's called Bitcoin.
But like that, but that's real though.
No, it's not.
Technically,
Go bring me a Bitcoin.
It is.
Bring me a Bitcoin.
It is currency.
Bring me a Bitcoin.
Bring me the internet. Bring me the internet.
Is that currency accepted?
Some
Yeah.
places.
Some places, so it's real. Bring me the
But didn't the
internet.
value drop tremendously?
I don't know. I'm not.
It dropped from
I know,
race to
just-
race.
They're permanent.
Coach Knight, bring me the internet and I can bring you some Bitcoin.
Everybody good?
Math?
All right.
Just math? Just doesn't.
You have a wonderful day, and we'll see you next time.
LOL.
Stay above the line, Lori Kate.